Hello everyone, myself Akash from SVC College, Bangalore. So today's topic is representing knowledge in an uncertain domain. So this topic comes under advanced artificial intelligence. So let's go through the topics and the contents. So these are the contents. At first we have the introduction, next challenges, probabilistic models, fuzzy logic for handling uncertainty, AI approaches for uncertain knowledge representation, evaluation and validation applications. At the last we have the conclusion. So let's go through one by one. So at the beginning we have the introduction to representing knowledge in an uncertain domain. So the first point is uncertain domain refers to areas where there is incomplete or amorphous information. Advanced AI system needs to be able to handle uncertainty in order to make accurate decisions. Representing knowledge in an uncertain domain is essential for AI systems to effectively operate in real-world scenarios. In the picture, you can see the uncertainty domains. So next we have the challenges in representing a knowledge in an uncertainty domains. So these are the three key points. Uncertainty arises due to the limited data and conflicting information or changing circumstances. Representing uncertainty requires capturing probabilistic relationship between the variables. And the last point is balancing the trade-off between the accuracy and efficiency in major challenges in uncertain domains. So these are the challenges. So next we have the probabilistic model for representing an uncertain knowledge. So at first we have Bayesian network, shortly known as BNS, are graphical models that are used directed acyclic graph to represent probabilistic relationship among a certain random variables. They are widely used for uncertain knowledge representation in various fields such as healthcare, finance, and NLP, shortly known as natural language processing. It also allows modeling dependency between variables and make a probabilistic inference based on observed evidence. Markov decision. It are undirected graphic models that are representing probabilistic relation among variables. They are used in situations where BNs are may not be sufficient, especially for modeling complex interaction between variables with a symmetric dependence. And a hidden Markov model, HMMS, shortly known as, are static models used to model sequence of observable variables whose underlying state are hidden or not directly observed. They are widely applicable in speech recognition, bioinformation, and NLP for modeling sequential data for uncertain transactions. And next we have the topic fuzzy logics for handling uncertainty. Fuzzy logic allows for a representation of a imprecise or a invalid information. Fuzzy set and membership functions are used to assign degrees of a membership to elements. Fuzzy rules and fuzzy inference engines enable reasoning and decision making in uncertain domains. Fuzzy logic helps in At first we have it helps in handling imprecise data. Traditional logic relies on binary values true or false, whereas fuzzy logic allows for a degree of truth. This is particularly useful for while dealing with the data that's not clear cut and contains imprecise data. Linguistic variables and fuzzy sets. Fuzzy logic used linguistic variables and fuzzy set representative vague concepts linguistically. For instance, terms like hot, cold, fast, or slow can be representatively in a fuzzy logic to capture their inherent uncertainty and subjectively. And the third logic helps in membership functions. Fuzzy logic employs membership functions to assign a degree of membership to employment in a set. Instead of a strict categorization, membership function enables a gradual transition between being a member or not, allowing for a more representation of uncertainty. So next we have AI approaches for uncertain knowledge representation. At first we have the probabilistic reasoning. Next we have fuzzy logic. And third place we have ontologies with the uncertainties. Last we have Bayesian networks in AI planning. So at first we have probabilistic reasoning. In the probabilistic reason we have graphic models such as Bayesian networks, Markov model, hidden Markov model are extensively used to represent uncertainty in knowledge. They made relations between variables probabilistic, allowing for reasoning under uncertainty. Next, we have the fuzzy logic. Fuzzy logic is employed to represent and reason with the uncertain or imprecise information. It enables the relationship representation of a uncertain through a linguistic variables and a fuzzy set, allowing for approximate reasoning. Ontologies with the uncertainty. Ontologies argument with the probabilistic extensions or fuzzy logic can handle uncertain knowledge representation. These ontologies allow for the excellent representation of uncertainty in a relationship between entities in a domain. Bayesian network in AI planning is the last one. So it are integrated into AI systems to model and reason about uncertain states, actions, and outcomes. This incorporation of uncertain helps in decision making and practical ability. So next topic is evaluation and validation of uncertainty knowledge representation. Metrics such as accuracy and precision and recall and FI source score can be used to evaluate the performance of uncertainty knowledge representation. Cross-validation technique can access the generalizability of a model. Real-world testing and user feedback are crucial for validating the effectiveness of uncertainty knowledge representations. So next topic is applications of uncertainty knowledge representation in advanced AIs. Autonomous driving systems rely on uncertain knowledge representation to navigate complex environment. So the next point is healthcare system used in uncertainty knowledge representation to assist in diagnosis and treatment decision. Last point is finance prediction model leverage uncertainty knowledge representation to make informed invest choices. So the last topic is the conclusion. Representing knowledge in an uncertainty domain is crucial for advanced AI systems to make accurate decision. Probabilistic model, fuzzy logic, MI, ML, and hybrid approaches are used to handle uncertainty effectively. Ongoing research and advancement will continue to improve the representation of uncertainty knowledge in an AI systems. So these are the following topics. So thanks for watching. Thanks for listening also.